Welcome to another episode of libGDX-Graph devlog. In this episode, I'll show you how to use a new feature, which is graph shader. So first of all, we start off with this simple pipeline, but instead of the default renderer, which uses the libGDX renderer, we're going to be using the graph shaders. So let's put it here into the pipeline. Just like normal renderer, it also has input for models, camera, and also lights. The only lights are not working, but this is something I will be working on later. But there is another list here of shaders that this graph shaders uses. And I can create a new shader. Tag is basically a string that is going to be assigned to a model to tell this graph shader pipeline part to render this specific model with this shader. So let's call it cover, because that's the kind of shader I will not be creating. And here click edit to open the shader editor. As you can see here, we have two tabs, the render pipeline and the shader that we are working on. Okay, so the shader output has three inputs: color, alpha, and alpha clip, which is very similar to Unity's one, the unlit one. We can modify the culling, which is basically which faces of the model should not be rendered. By default, it's only the back face that should not be. This is opaque model, and blending using mode alpha. It doesn't really matter in case of opaque mostly. Okay, so what we're gonna do is gonna start off with the diffuse texture that is in the model. Because it's in the model, we're gonna look into the material, because it's part of the material. By default, it uses the white texture. You have a preview here, but we can also choose a different one, and let me choose one. Okay, so I'll be using the seamless rock face texture. So this is the texture I have. I can, of course, I cannot connect the texture directly to color because it's of type texture. So I have to sample it. So we sample it here with the sampler to collect the output of this, but this is not enough. You have to also provide the UV. UV is part of the model itself, so the model attributes. Here, I probably should rename the name of the menu. Okay, and we have now the sphere that has this texture applied to it. Okay, so what I want to do now is basically something like a, I don't know, snow cover that is on top of the model rendered, as if snow was covered. So let's create a new constant color. White is fine, and we want to mix it with, so this is in mix, and we will mix this color, the white color, with our texture and output this to the color in here. And we have to provide what kind of value should be, how do we mix this two. So let's use a constant float. For 0, we are using the first texture, and the closer we get to 1, the higher value of the first one is being used. So the second one is being used, but we want to only have it on the top. So let's start with maybe a normal of the sphere. So for each face or each point on the sphere, we'll have a normal, which is basically a vector that points perpendicular to the surface. So for example, on the top here, it's going to be pointing up. The more to the left you go, it's going to be pointing more and down. So let's use the normal attribute, and we want to use the world. So we have here choice of world coordinates or object coordinates. Object is coming directly from the model, and the world, it applies any changes you've done to the actual model instance, for example, rotation. That's why, because we want to have, regardless of how this model is rotated, we want to always show the cover on top of the model. Therefore, we have to use world coordinates, and let's use only the y part of it. So we split this normal, and we only use y coordinate of the vector, and we're already seeing similar to what we want to see. So we have this white part on top, which depends on this color here, But the problem is that this gets darker. And the reason why it gets darker because y is actually negative from here going down on all the half of the lower part of the sphere. This is not what we want. Therefore, we'll create a clump here, which is a node that takes the input and you provide minimum and maximum. This node will output. So we'll provide two vectors, two floats, 0 and 1, because this is going to be our minimum and maximum we want to use. And we are input instead into the lerp here. Okay, so we are seeing now more what we want to see, which is the cover is only on the top. However, what happens if you run a very heavy blizzard? So snow is not snowing directly from top, but you want to cover your model from any direction. So let's create here a new vector 3, we'll call it direction as a property. We'll put the default of up, and we input it here. So let's say that this is going to be the direction on which we want to put the cover on. And what we have to do now is use a dot product, which is I believe it's advanced at the moment. Yes, dot product. So what this does, the dot product, is it looks at the two vectors that you input here. And if the two vectors are parallel and in the same direction, then the result of this is going to be 1. If it's parallel in the opposite direction, then the result is going to be -1. If they are perpendicular to each other, then the output is going to be 0. And the closer they are to each other, the value is going to be increasing. So for example, in here, so let's say that our direction at the moment is up. So let's say this is our vector, and the normal is in here, the value will be 1. The closer you go, it's going to decrease, and here it's going to be 0 because the vectors are perpendicular. And then it's going to keep decreasing until it gets to here, it's going to be -1. So you want to use this instead of the split here. As you can see, nothing has changed. That's because we are using the same vector as for the direction of the cover. But if we now modify the value here, as you can see, the direction is now 1, 1. So somewhere around here, the vector looks like this. Therefore, the cover is from this side. Okay, so what we can do now is we want to be able to modify the amount of snow you have here. Sorry, I had a slight malfunction here. So let's now create a new property here for the amount of the cover. We created the node here for it, and what we want to do is want to multiply the dot product with the amount. And of course, we want to also keep this clamped. So in here, create a math arithmetic multiply. We'll multiply these two values. So at the moment, the value is 0. If we set to 1, we set to 5. We have, as you can see, the higher it is, the more cover we can see here. Okay, so that will be good enough for a snow, but let's do something more interesting. Let's do a splash of blood on the model. So let's change the color to something bloody red. I don't know, let's use this. However, blood doesn't behave really this way because we want let's do brown probably, something less brown. Okay. We want to have some kind of irregularities in here. So the way we can do this is using the noise. We have a choice of simplex noise 2D or 3D. And I'd like to use here a 3D. That's because I want this irregularities to be the same. Because normally I could use the noise 2D and use UV for this. However, if I use UV, then if a model that we're going to be using this shader to render with, if the UVs in some points of the model are more stretched than in others, the irregularities are going to be a different size in different parts of the model. And if I use a nose 3D, I can actually use the location of the position of the pixel that we are rendering. So I'll take a position here, and this time I'll use object position. That's because if object moves within a world, I don't want the irregularities to change. And I have one additional property I want to say, which is scale, which is the size of the irregularities you will see in a moment. So I want to create property scale, and let's see the result of this. So let's do math merge. So this is returning a float. Let me turn it into 0 and 1s and show you the output of this. So temporarily we're set here. So we're seeing this kind of irregularities here. The higher the scale, the more of them you will see. Smaller is going to be, the irregularities is going to be bigger, like bigger blobs, or you can say like tiny droplets of blood. Well, the thing is that this is not exactly what it is, because simplex noise produces values between minus 0.7 more or less to plus 0.7. So what we want to do here, let's connect it back here, is actually to remap these values to 0 to 1 to have like more even output. So for this we'll use the math, it's here, advanced remap. We provide the input, and we now define two vectors, vector 2s, which define minimum and maximum. So as I said, the minimum of this is minus 0.7, and the maximum is 0.7. And we want to remap it to, so we want to remap it to a constant vector 2. Let's say we want to have always a pretty big cover of blood in these. So from 0.5 to 1. Okay, and we will connect the from and to here. And what we want to do here is multiply it with the result of the dot product multiplied by the amount. So let's move these a little bit lower here. Create another multiply node here. Multiply the output of this and this, and connect it here. Okay, so we're already seeing kind of, let's move them to the front. I think it's going to be this one. No, nice one. Yeah, so we are seeing here, let's say amount 1. So we can be seeing tiny droplets, but yeah, so this looks more like blood-ish here. Yeah, you can also work here on the how big the impact of this is here. Maybe something like this. Okay, so this is going to be my shader. I'll save it. And now I'll show you how I use this in the program. So in here I have a program that uses this shader. We can modify the amount here. We can modify the scale, so the size of the droplets. You can consider it this way. And we can modify the position of the direction of the left to right and position of the splash direction. And the way this is done is, let me jump in quickly into the program here, which is here. So in here, this code, I create the model. I assign the texture, the same texture that was used as a preview in the shader, so the seamless rock. So this is the important part. I tell this model that is being created from this this model instance created from this model, that I add an additional attribute to the model, to the material, sorry, which is called graph shader attribute. And here I specify that this should be rendered by a cover shader, which is the name of the shader. If you take a look here, if you jump here, this is the name of the shader, cover shader. This is the tag that you set on the model saying this model is something that should be rendered by that shader. And the UI, what it's doing is setting the properties. I have here the util class that allows me to directly take an instance and set the properties that are being used there. And everything else is exactly the same as it was before using the pipeline. Yeah, that's gonna be it for this. So let me show you once again. The result is we have this blood splatter that you can define the size of droplets and the direction from which it comes, or maybe from the bottom somehow it got stained. Yeah, so I hope you found this useful. If so, please like the video, as it will let me know what content to make. Please also subscribe to the channel to be notified of any new videos. Thank you for watching. Bye.